Here we start the statistics and probability block of standards. And in 8.SP.1, 2, and 3, we're really dealing with the idea of a scatter plot. So in this particular problem, some data found in the table was plotted. That's what the dots represent. And then a line of best fit was drawn through there. Now remember, a line of best fit is essentially a line that best fits all of the plotted ordered pairs. And since this is a situation where the dots don't line up all perfectly in a straight line, we're trying to estimate what a linear function might look like that best represents that data. So basically, this is an estimate, okay? So part A, we are asked for the approximate B value of the Y-intercept. Well, we can see right here on the graph that the Y-intercept is right there. Now, it looks like it's around 0, but it looks like it's a little bit above 0. So this is just an estimate. So I am going to go with saying that that B value of the Y-intercept is maybe 1. Now we need to give an approximation for the slope. Now remember, this is just an estimate. So what we have to do here is we have to find two ordered pairs that are relatively close to perfect. They don't have to be exactly perfect, but they got to be close to perfect. So what I'm going to go with is I am going to go with this point right here and this point right here. It doesn't matter as long as they're pretty close. So I can see that my Y value axis is going up by 5. So we just had a rise of positive 10. And my X value numbers are going by 2. So we went from 12 to 16 down here. So I had a run of positive 4. So that means a rise of 10, a run of 4, that reduces to 5/2. So I'm going to go with 5/2 for my slope. And now once I have the slope and the Y-intercept, of course I can put both of those things together. And I have my linear equation that best represents that model there. Now, part D, it says, based on the relationship, the linear model shown above, the greater the distance from school, so in other words, the greater the distance from school, the greater amount of time that it takes to get to school. Well, clearly that is a true statement because, for example, at 4 miles from school, it took the person 10 minutes, whereas at 18 miles from school, it took them around 45 minutes. So that last statement, of course, would be a true statement. Here we continue with the statistics and probability set of standards 8.SP.1 and 2 and 3, where we are dealing with the idea of a scatter plot. So we can see that this situation represents the amount of water in a pool over a given amount of time in hours. This is a scatter plot because the dots that are plotted, the ordered pairs that are plotted, they're kind of scattered a little bit. And then the red line that goes through them, that's the approximate line of best fit. So in this particular problem, we are asked for several things here. First thing that we're asked for is the estimated value of the Y-intercept. Now remember, this is an estimation. So if we look, right there is our Y value. All I know is that it's somewhere between 13,600 and 14,400. And there's a spread right here of 800. So I'm going to say that maybe that's around 13,800. So that's what I'm going to go with for my Y-intercept there. And we just have to be close. 13,800 is what I said I thought it was. Now, as far as the slope goes, we're going to have to zoom in a little bit here and try and find two ordered pairs that are close to perfect. And since this is just an estimate, they don't have to be totally perfect, but they've got to be close. So I'm going to go with that one right there and maybe that one right there. So this line is going downhill from left to right. That means we have to have a negative slope. So let's see here. We're going by 800ths on the y-axis. So we had a rise of 1600. And then I'm running to the left. We're going every other line. So the tick marks are just by 1. So 1, 2, 3. So we have a rise of 1600 and a run of 3. That's already reduced. So I'm going to go with 1600 thirds for my slope. And remember, it's negative, and I should have said that when we were running to the left. That would have been a negative 3 running to the left. So it's negative 1600 thirds. And we can now put those two things together for our equation. Y equals negative 1600 thirds x plus 13,800. And then, based on the relationship, the linear model shown above, the less amount of time that has passed, the less water there is remaining in the pool. Well, you could check it really quickly. At 2 hours, there was around 12,400 gallons in the pool. And over here at 15 hours, there is only 5,600. So the less amount of time, actually, the more water is in the pool. So this is a false statement, and that's a typical wording of some situation that has a negative slope.